In this video, we're going to talk about factoring specifically, and we'll get into solving a little bit later on, probably not in this video. So, quick recap from chapter 5 back from algebra 1. There are different types of trinomials, different types of polynomials that we can factor. So there's a general trinomial, which is where we just unfoil essentially. So like in algebra 1, we started with this and multiplied to get that, and now we're working backwards. There's a perfect square trinomial, which when you unfoil it, you get two identical factors, which you can then just write as a binomial being squared. And we had a difference of squares. We have a perfect square minus a different perfect square. Take the square root of the first plus the square root of the second for one factor and minus for the other factor. And then in general, we just always have a greatest common factor, right? The GCF. If it's a binomial, trinomial, whatever kind of polynomial, if you have one, you need to be able to factor out the common factor. You'll end up with a monomial times something else. Those aren't new. You've seen them many, many times. The new things are going to start right now. We are going to have a sum of cubes and a difference of cubes thing to factor, which means you have to know your cubed numbers. Okay, in OneNote, there is a page on there that shows you all the different numbers that you should have memorized, or at least be able to figure out quickly without a calculator for what needs to be squared, cubed, and to the fourth, and all that fun stuff. So, if you can spot a perfect cube number, plus a different perfect cube number, you will have one factor that is the cube root of the first plus the cube root of the second. Your remaining factor is going to be a trinomial where you have whatever the cube root of that first term is squared, which is kind of a confusing thing to wrap your head around at first. And then you'll have minus the cube root of the first times the cube root of the second, and then plus the cube root of the second thing squared, which sounds super obnoxious. But let's look at a very quick example with nice numbers. I'll have one variable and a nice number. So if I have x cubed plus 8, this is x times x times x. We'll basically think a equals x. Here, for 8, that is 2 cubed. All right, so if it's 2 cubed, my process says a plus b, well, x plus 2. I should put this as b equals 2 to make it more straightforward, so I apologize for that. X plus 2 times a squared, well, it's x squared, minus a times b, x times 2, which we will usually write as 2 times x, and then plus b squared, well, plus 2 squared, which I hope we can all just jump to being 4. That's how that process works. Where it can get kind of confusing is we also have what's called a difference of cubes. You again still have perfect cube factors, or cube pieces of your polynomial, but now you have a subtraction in the middle here. Your beginning term is where that subtraction goes. Then, in your remaining trinomial, everything is a plus. So in both of these, sum of cubes and difference of cubes, there are 2 plus signs and 1 minus sign, neither of which occur between parentheses, because again, we're multiplying, we're factoring. If you have a sum of cubes, it's in the middle of the trinomial. If you have a difference of cubes, it's in the middle of the binomial. That's one way to remember it. Whatever works for you is whatever works for you. You could use these exact same numbers that we just did. If we had x cubed minus 8, it would become x minus 2 times x squared plus 2x plus 4. The numbers will be the same. The signs will be different. These two things are not equivalent. They are not equal to each other, so it's important that you know where your signs are. Okay, so when factoring, there is a general process you need to always follow. First thing is, can you factor out a greatest common factor? If you can, you have to. First, always, no matter what. Then, once you factor out a greatest common factor, if there is one, what's left is the next thing you basically start the list over. Is there still a greatest common factor? If there is, it means you didn't get it the first time. You just got a common factor. Okay, so there's not a greatest common factor anymore, or there wasn't one to start with. Now we determine what type of polynomial you have. If you have a binomial, you're going to look to figure out if it's one of these first three things. If it's a difference of squares, sum of cubes, or difference of cubes, we have a factoring rule for that, and we use that. If it's something else, you're not going to factor it. You're done. Okay? If it's a trinomial, this part right here is a generic reminder of how to factor a trinomial, but we have to remember this is specifically for when a is equal to 1. If a is not equal to 1, you have a little bit more of a nuanced approach to it because you have to find some more specific factors. So because of that, it's always a great idea to remember to FOIL and double check that a thing actually multiplies out to what you said that it should. And then the new one that we're going to talk about, which I have an entire typed out example problem for you, is a tetranomial. Tetranomials are 4 terms. This one is brand new, and we're going to call this method factor by grouping. Factor by grouping is something that some of you have some experience with without knowing that's what you have experience with. So if you ever did the AC split method for factoring trinomials, that was just taking a trinomial, splitting it into a tetranomial, and doing factor by grouping. We just didn't call it that. So in this example, we have 1 cubed minus 2x squared minus 9x plus 18. The 1 doesn't need to be written there, but put it there just for simplicity, essentially. So you get your 4 terms. You're going to split it into 2 terms. So this first step, I just went like this. Okay? But notice that when I did that, my signs wouldn't match here. So I'm actually treating this as a plus negative 9. That negative is a little close, so we rewrite that. If you had a subtraction, it's a plus and negative. We want that plus sign in there. It makes life easier. Then what you do is you find a greatest common factor for each of the binomials. So in this first one, the only thing those two have in common is an x squared. X squared times x gives me the x cubed. X squared times minus 2 gives me 2x squared. Okay. In this one, my GCF is a 9. But I'm going to factor out a negative 9. Because what we want, like it says here, we want matching sets of parentheses. Okay, if I had factored out a positive 9, I would have ended up with an x plus 2 for that second piece. Then that wouldn't match and we wouldn't get to do what we're about to do. So that's why I factored out a negative 9. So now, essentially what we're doing is factoring out a GCF again. All right? This time, since these two things match, we put it together here. And then this piece and this piece go right there. X squared minus 9 is what was left. So the reason why I said we're essentially factoring out a greatest common factor again, the process for distributing, if I were to do anything here, would be x minus 2 times x squared. That's this first piece. Then you take x minus 2 times this negative 9, which is that second piece. Right? That's a secret kind of hidden factor out of GCF that you don't really think about, but that's why this works. Now, what we did is we factored out a common factor. That's a binomial. But we're not necessarily done, so we need to check if we can go any further. So that x minus 2 is done. Absolutely, obviously, there's nothing more we can do. X squared minus 9, that's a difference of squares. So the square root of x squared is x. Square root of 9 is 3, 1 plus, 1 minus. So in this case, I get to see that x plus 3 times x minus 3 times x minus 2 is equal to my original thing of x cubed minus 2x squared minus 9x plus 18. If I want to, I can absolutely FOIL and distribute and multiply this thing out to double check, but I should be comfortable getting GCFs along the way. Now, a question that might get asked is what happens if I wrote it like this instead? Oops, not minus 2 again, sorry. Minus 3. If I wrote it like, that's the exact same thing. If I wrote it like that, doesn't matter. Okay, with multiplication, you can multiply in any order. We're still multiplying the 3 sets of parentheses together. We are good to go. That would be perfectly fine as well. Okay. This is a great typed out example for you to look back to and refer when you are getting stuck on factor by grouping, so make sure you are practicing that. I hope everybody has a great day.